Okay, now let's move to question 7. Well, this question asks us about the value of inlet and value of outlet given the as YZ. So this is a mass balance. So the concept is pretty simple, where we need to know that the input value must be equal to output value. So everything should be the value in and out should be same. So the first question asks us what is the total number of mole for the top outlet. So we know we have 1,400 kilomole for inlet, and we have top outlet and also bottom outlet. So for bottom outlet, the value of the bottom outlet is 500 kilomole. So for sure, the top outlet will be 1,000. What should we do is inlet equal to outlet 1 plus outlet 2 so we need to know that for this one, inlet equal to outlet 1 plus outlet 2. So we have inlet 1,500. Let's say this one is outlet 2, this one is outlet 1. So you can call it X, and then outlet 2 is 500. That's why if we change it left hand side, so S will be 1,500 minus 500. So that's why we got 100. So we can determine that this the top outlet, the value is 1,000 kilomole. And then for the second question, so the question asks us about what will be the value of X and Y in top outlet if both components have the same number of moles. So we already know that this top outlet is 1,000. Both have the same number of components, so X will be 500 and Y also will be 500. And next question asks us about what is the total value of Y for outlet. For the outlet, so this one we know that order 500. This one is 500. So for the bottom outlet, we know that the Z bottom outlet consists of two components, Y and Z. And for the Z, we have 100 kilomole. So for sure, Y will be 400. So for the outlet, we need to add these two components Y. So we have Y in both outlet. So for the top outlet, the value of Y is 500, while for the bottom outlet, the value of Y is 400. So we add it together. So that's why we get 900 kilomole. And then we move to the next question. The question asks us about the total value of X for outlet if the inlet is double. So for sure, so the value will be double too. So the value will be so now at the moment we have 500. So if the value doubles, so that's why we need to type it 2, because it is a double. So we will get 100 kilomole of X. So this is how to answer this kind of question. So this is a specific question where if we go to the industry, we go to the factory, they are usually and always upscale all of their reaction. So that's why we need to calculate everything in a good order in order for us to get the required amount of product. So you will go through to all of this calculation. I think in year 3, you will learn in detail what about all of this kind of calculation. However, for the introduction of chemistry, what you should know is you should know the concept and how to apply the basic concept into a simple problem. And then it's about Hess law, and also enthalpy. Enthalpy is an important energy that we calculate in chemistry, where the enthalpy is about the internal energy. If we want to make a reaction, so we need to ensure what kind of enthalpy it possesses, and is endothermic or exothermic. So this question, for question 8, is it asks us to calculate the delta H, the enthalpy for the process as below. So here is the product. Give it product, so we can name it as equation 1. So equation 1, this one I name it equation 2, and equation 3. So by using the following information, we need to determine the delta enthalpy for this process. So we can use a Hess law. By using Hess law, we can determine the enthalpy of any reaction that we want to know. So for this law, so we need to determine. So for example, we need to determine because in the Hess law, there are a few theory behind it, where we also can invert this equation. So if we invert the equation, so the value will be changed from negative to positive, for example. So for example, in this question, so we have Hg2Cl2, this is mercury chloride. This component, if this component will separate, and then it will produce mercury and also chlorine gas. So you see here, in this equation, the mercury chloride is here, fiber is here, so that's why we need to invert it. So that's why we need to like this. So and then what we need to do when we invert it is we need to try to change its notation also. So from negative 41.2 kilojoule, now this equation will become 41.2 kilojoule positive. And same goes to this one. So we have 2 mercury here and Cl2, while here we have Hg and Cl2 in this side. So we need to move it to the other side. That's why we need to change the equation and also the value itself. So that's why we have 234 kilojoule. So from here, what we can do is we can eliminate any element that we want. So we want to make the equation as balanced. So once we eliminate this, so when we comment this equation, so we will have mercury chloride here, Hg, you add it together, so 2Hg plus chloride gas. So it's same with this one, with our intended or final equation. And then what we can do is delta here is the summation of this one. We need to add both of this. So I label delta H1 and delta H2. So the total delta H equal to delta H1 plus delta H2. So the value for delta H1 is 41.2 kilojoule, and the value of delta H2 is 284 kilojoule. We add it together, so we will have 265.2 kilojoule. So that is the answer. And then question 9. So this question 9. Shows the reaction between methanol and salicylic acid that we produce ester methyl salicylate. The rate of formation of the ester is given by the expression rate equal to K, concentration of methanol, and so concentration of salicylic acid. In chemistry, this sign is means concentration. So where K is constant, so the question asks us 2 components. The first one is to calculate the molecular mass of each species, and the second one is to calculate the rate of the reaction using the formula given. So to calculate the molecular mass, for first thing first, we need to know how to read, how to interpret this drawing. So from the drawing, we know that we need to know how to improve it. We need to determine the molecular formula for each species present in the reaction. So to define each species, so let's say this one I name it species A, species B, species C, species D. So for the species A, we can determine that there is 7 carbon, 6 hydrogen, 1, 2, 3, 4, 5, 6, and 3 oxygen, 1, 2, 3. So AC7, H6O3, and again, by using the concept that we learned before, we can identify the molecular mass for each species, and you need to refer, of course, you need to refer to the table, determine every mass of every molecular mass of each unit, and then for B says OH, so it's easy. So for C, we need to determine the molecular formula for this component, whereas this one is methyl salicylate. So for the carbon, we have 1, 2, 3, 4, 5, 6, 7, and 8. So that's why we write C8. For hydrogen, we have 1, 2, 3, 4, 5 plus 3 here, 5 plus 3 is 8, H8, and O, we have 3 O, 1, 2, 3. So the unit of hydrogen is 8, while the unit of oxygen is 3. C is H2O, and again, by using the concept that previously we learned at question 1, so we can determine every molecular mass for each species here. And then for the next question, the question asks us to identify the rate of the reaction given this the formula. So rate equal to K, concentration of methanol, time with concentration of salicylic acid. And from the question give us each rate of each give the information, a few information. So we need to know how to extract the information from the question. So here is K is the rate. This one is concentration of methanol. We have 3.2 and concentration of salicylic acid. And the question asks us also to give our answer in 2 significant figures. So first thing first, we write the formula and then plug in all the number here. So rate equal to K. K is 3.067, while the concentration of methanol is 3.2, and the concentration of salicylic acid is 1.1. So we calculate it, so we will get 10.79584. Since the question asks us to write the answer into significant figures, so we need to know how to run off. So that's why the question is, the answer is 10.80 more dm cube. This concentration, this one is the rate unit, the dimension. So we cannot, if we use, we can eliminate the dimension, and we can this the final dimension. So this is how we answer the question 9. And I hope you can understand it until here, until this point. So if you have any difficulties, please let me know so we can try to solve it together.